I blew it on my second video. So the third page here is the third or fourth page. I don't know. Anyway, this day in history, Sugar Ray Leonard, which is a guy that you probably never even heard of. Anyway, he took his title back. He was one of the most prominent boxers of the time, and pretty interesting fact there. So you can see that the three problems on this page, I want you guys to actually attempt before you. So pause the video and work out the first problem. Watch my example, see if we get the same answers, and then move on and do the same for the other two. Okay, so you can see problem number one, you actually get a picture of it. You're not always going to get a picture, which is why you need to know how to graph all your parent functions. But you should be able to tell here, I didn't label the two functions. I'm trying to find the area of the shaded region, and the first function is the x plus 1, so y equals x plus 1, and the quadratic is your x minus 1 squared. So all I'm asking you to do here is set up the integral. And again, your main job is just to figure out, okay, what are the dimensions of that rectangle? Because you're adding up an infinite number of rectangles, areas. Okay, and the integral, the limits of integration, we're going to go from left to right, are, you can see the x-coordinate of the point of intersection on the left is 0, so that's where you get that. And then the x-coordinate of the point of intersection on the right is 3. So we're going to go from 0 to 3. Okay, so that's the first part. The second part is what in the world is the length of the rectangle and what's the width? Well, we already know the width. The width is always going to be your dx. But the length, right there, again, it's the top curve minus the bottom curve. So what's the top curve? That's your x plus 1. And what's the bottom curve? Well, that's your x minus 1 squared. That's your length, okay? Just to keep in mind. That is the length right there. Okay? And your dx is your width. So that's it. You could clean it up a little bit. I'll let you do that. Number 2. Set up an integral that would yield the area between these two curves, x squared minus 2 and y minus 2. So this is where you need to be good at graphing. Super helpful. So x squared minus 2, you're going to draw this graph. Let's do the easy one first. Y equals 2. What color would be good there? So y equals 2 would be here. Okay. And x squared minus 2, that's a parabola that opens up. Okay. And the parabola that opens up, what color would be good? This one here. X squared minus 2 has a y-intercept of negative 2. Comes up here like this. Okay, and you need to be able to figure out what those points of intersection are. Okay, so that's what we're trying to find. Here we're trying to find the area of this region here. Okay. And to find the intersection points, you just have to notice that y, the y-coordinate, equals x squared minus 2. That's when you set the two y-coordinates equal to each other. Y equals x squared minus 2 and y equals 2. Well, when are they equal to each other? Well, they're equal to each other when x squared equals 4 or when x equals plus or minus 2. Okay, so we're going to take the square root of both sides. We already did that. And we get x is plus or minus 2. So well, we already knew that, right? The x is equal to y coordinate is 2, but the x over here is 2 and the x over there is negative 2. Okay, so we have that, and so we know our left boundary is negative 2 and our right boundary is positive 2. It's always if we're integrating from left to right, the lower limit of integration is the x-coordinate of the left point of intersection, and the upper limit of integration is the x-coordinate of the right point of intersection. Okay, and again we have length times the width. Well, we need to draw a rectangle. Well, let's get a different color for the rectangle. So Let's use that one. Any rectangle will do. Now, I'll show you a different way to do this because we do have some symmetry here, so you can use some shortcuts here, but I'll get to that in a second. But the rectangle here, the length, again, of the rectangle is the top curve. Let's just do this. Length times width. Okay, let's put that up here. So length times width. So the top curve is 2, and the bottom curve is your x squared minus 2. And your width, again, is your dx. Okay, let's show this. Negative 2 to 2. 2 minus x squared plus 2 dx, which, if you actually did have to simplify this, you can simplify that to 4 minus x squared dx. Okay, and that's a relatively easy definite integral to calculate. So that's the answer. That's one way to express your answer. Okay, the other way, if you notice over here, you've got symmetry going on. If you just integrated from 0 to 2, so you could do this, or integrated from 0 to 2 of the same function. So if you, after simplifying, you get 4 minus x squared dx. Okay, but you'd have to double that. So you could double that like that. Oops, let me show that. So again, when you have symmetry, I would encourage you to use that, use the facts of symmetry, so that when you're finding area, just find the area on one side of the y-axis and double it. Okay, because when you have a limit of integration at 0, then it basically cuts your work in half. Okay, I'm going to try to squeeze this last one in here in a few minutes. Last one. Integral that would yield the area between the two curves. Now, we already are given that the curves are expressed in terms of x. So we have x equals 4 minus y squared and x equals y minus 2. Well, the 4 minus x squared is this guy here, 4 minus y squared, and the y minus 2 is this guy here. Okay, so when we draw a rectangle, remember that the length of the rectangle, so area, equals, we'll get to the limits of integration in a second, but the length times the width. The length is the right minus the left. So the right curve would be 4 minus y squared minus the left curve, which is, careful with parentheses here, is y minus 2. And don't forget the dy, because we're going to go from the lowest point to the highest point. Okay, so we're going from bottom to top. And when we go from bottom to top, the lowest, or the lower limit of integration, is the y-coordinate of that point, which is negative 3. And the top boundary, or the upper limit of integration, is the y-coordinate of the point on top. So that's the 2. And so we could simplify that a little bit. Negative 3 to 2. 4 minus y squared minus y plus 2 dy. And let's just make it look a lot cleaner. Okay, negative 3 to 2 of 6 minus y squared minus y dy. So hopefully this is starting to make a lot of sense to you, and this might be a breath of fresh air after that last test. And I will see you in the next video.